Okay, so like the last tutorial then, we have the molarity again and we want to find the mass. Just like in the last tutorial where it was calcium chloride, CaCl2. So the molarity that we have this time is 0.075 is the molarity. It's a different substance, sodium, it's NaClO4. So this is what we've got to find the mass of when it's 0.075 moles. Okay, so in this question you've got a formula at the very beginning of this question. It's the number of moles is equal to the mass in grams over the molar mass, which is grams per moles. So this is just a convenient formula to remember because it comes up in more complex questions further on. But to make it more simplified, I've just done this method out over here. Okay, so molar mass, then we just take our molecule and all we do is we get the individual atomic mass units and convert them to grams straight off. So sodium is 22.99 straight off the periodic table, chlorine 35.45, and 4 oxygens, boom, there it is right there. Add them up, you get 122.44 atomic mass units. Converting to grams then it is 122.44 grams. Okay, so that's our molar mass, or 1 mole of the substance. Okay, and the next line then says, look, mass in grams is equal to the number of moles by the molar mass. Now that's coming directly from up here. We've got the mass here on the right hand side of our equals. The molar mass is divided on the right, so when you switch sides it changes to multiply, and I just have that arrow showing that it switches sides and then it becomes multiplied, which is what you see down here. There it is right there, molar mass multiplied by the number of moles. Plug and chug the numbers and you end up with 9.18 grams, and you've got that on the righty over here as well. It's easier methodology, but as I said, this is a formula that comes up a lot and it's just a case of getting familiarized with it. Okay, so it's getting a bit more interesting now here. We're talking about platinum atoms in 45 grams of platinum. Now I think that this is a typo error here and shouldn't be in it at all, okay? Determine the number of platinum atoms in 45 grams of platinum, okay? So what we're doing is we go directly down to the formula down here. The number of moles, which is what we're working out, we have 45 grams, which is given, and then for platinum it's 195.08. That's the molar mass of, in other words, 1 mole. Basically if you read straight off the periodic table you get 195.08 as the atomic mass unit. Converted to grams then gives 195.08 grams, and that's in 1 mole of platinum. Okay, so we'll work out the number of moles then from this, and number of moles is equal to 0.23 moles, just done by straight up division. Okay, so 1 mole of platinum is equal to 195.08 grams. Switch left with the 195.08 and it divides on the left, so 1 over 195.08 moles of platinum is equal to 1 grams this time, and then 1 over 195.08 by 45 moles is equal to 45 grams. So I've just gotten it around 45 grams, and then 45 grams stays as is on the right hand side. Do the sums on the calculator and you get 0.23 moles, which is the answer that's here. Now we just got to convert 0.23 moles into the number of atoms using Avogadro's number. So this finishes really easy then. Look what we've got circled here. 1 mole is equal to 6.023 by 10 to the 23 atoms per molecules, okay? Per moles, I mean to say on that. Whoops, yeah, that's exactly. It should be atoms per mole. That's what that should be there. 6.023 atoms per mole. That's the point there. But we don't have 1 mole. We've got less than that. We've got 0.23 moles. So we just introduce a 0.23 and multiply it on the right-hand side, which is going to reduce down. And yeah, it comes down considerably, I think you'd say there. So 0.23 moles is about 1/5 of what it was, which is 1.39 by 10 to the 23 atoms.